12. So this week we have continued our lesson, which is logarithmic function. Last week we have talked about how do we find the domain of definition of a logarithmic function. This week we learned how some operations, what are the rules of calculations on logarithmic function, and we started with limits. So let us make a quick revision for the things that we have learned this week. So first of all, we already learned how do we find the domain of definition of the logarithmic function. This week, we started by the properties of logarithmic function. The first property, which is the logarithm of product, which means if I have len AB, sorry, we can split this into len A plus len B. Of course, we have to take the condition that A is positive and B is positive. So every time you are going to solve or use the properties, you have to take condition that the input of len should be positive. Also, if we have len A plus len B, we can join them in one len and they become as product. So let us take an example. Here we have len x plus len x minus 3. So we can say that this is len A plus len B. So we can join them into one len. So we will have len x into x minus 3, which becomes len x squared minus 3x. So this is the property of product. Of course, they took condition for every len. Here we have two lens, so I have to take two conditions. The first condition that should be greater than 0, and the second condition x should be greater than 3. Okay? The second property is the logarithm of a quotient. So what if I have len A over B? I can split the len into len A minus len B, of course, under the condition that A is positive and B is positive. And what if I have len 1 over B? It's minus len B. Do you know why? Because len A, which is len 1 minus len B, len 1, you know that it's 0. So what's left is minus len B. That's why len 1 over B is minus len B. Also, here we have the logarithm of a power. If I have len AP, the P is the power of A, we can put the power down. So I have P len A. And you have to know that len radical A is half len A. How did I get this? Because radical A, it's written as len A to the power half. You know that the radical is to the power half. And now you put the power down, so half len A. Okay? Um, so as a conclusion, we will have that len AR equals R len A under the condition of A is positive. Look at these two examples. We have len 2.15 to the power 7. So you put the 7 down, 7 len 2.15. Okay? Here we have len 5 plus 1 over 2 len 8 minus 3 len x. I have to put them all in one len. First of all, you know that power 1 over 2 len 8, it's written as len radical 8. So we have len 5 plus len radical 8. What's 3 len x? We can put the 3 up. I told you you can use the property in both ways. So you can use len AR equals R and len A, and you can use R len A is len AR. So 3 len x is len x to the power 3, and those two, it's the product rule. So I have 5 radical 8. And if I have minus, this is the quotient rule. So 5 radical 8 over x power 3. Okay? So these are the properties of len. They are very easy. We have 3 properties: the product property, the quotient property, and the power property. 3 properties only. I use the properties most of the times in the equalities and inequalities. Let us first look at this. If we have len A equals len B, as if you get rid of the len, so A is equal to B. Len A is greater than len B, get rid of the len, so A is greater than B. Len A less than len B, get rid of the len, so A less than. So you have to pay attention that every time you solve an equality or inequality using len, you should have len to the left and len to the right, one len to the left and one len to the right in order to get rid of them to have A equals B. If you look at these examples, look at the first one. We have len x plus len x plus 2 equals len 3. I told you that you should have one len to the left and one len to the right. I already have one len to the right, so I'm done with this side. I have to work on this side. This is the product property. So len x plus len x plus 2 will give me len x into x plus 2. So you do them as product. Now I have one len to the right and one len to the left. I get rid of them. So I get x into x plus 2 equals 3. I solve it as an equation. And we have two roots, 1 and minus 3. Before start solving, you have to take conditions here. I have two len, so I have to take two conditions. The first condition is that x greater than 0. And the second condition is x is greater than minus. So x greater than 0 and x greater than minus 2, I will go with x greater than 0. In this case, 1 is accepted and minus 3 is rejected. So the only solution for this equation is x equals 1. And now we're going to solve the second one, which is inequality. Also here we have len x, the same case, but we have greater than. Of course, I should have one len to the left and one len to the right. So I joined these two as product as we did before. Of course, you took the same condition, okay? So I have len x into x plus 2 and len 3. So I get rid of the len and I will get x squared plus 2x minus 3, which is positive. And I solve this as we used to solve in grade 10 when we have two roots, 1 and minus 3. You put them in a table of sign. Oh, what's this? Sorry. You put them in a table. I have minus 3 and 1. Okay. Same, opposite, same. So you have plus, minus, and plus. So we wanted positive, so this part and this part, but you know that from the condition x should be greater than 0, so this part is excluded, so the only solution is from 1 to plus infinity. I wish that this is clear for solving equations and inequalities. We didn't actually talk about the derivatives, so I'm going to start with the limits. In the limits, we have two rules to study very well. Len plus infinity is plus infinity, and len 0 is minus infinity. Okay, so that's the only two properties for len. Len plus infinity is plus infinity and len 0 is minus infinity. But you have two things to study. If you have len x over x, when x tends to plus infinity, you can put it directly 0. And if you have x len x, when x tends to 0, you can put it directly also 0. So that's the only properties for the limits. Next week, of course, we're going to start with the derivatives. And when we are done from the derivatives, we start variation. We start a complete question where you are asked to do the variation of the function in order to draw the curve at the end of the lesson.